Hi everyone, welcome back. And today we'll be doing this question called product of array except self. This is a medium rated question and it's also part of our series that we're trying to finish. So let's just jump straight into it. This is a question that says given an integer array nums, return an array answer such that answer of index I is equal to the product of all elements in the nums except for the number at at that specific index. And they also assure us saying that the nums are guaranteed to be an integer, 32-bit integer, and we must write the algorithm in O(n) time complexity, and we are not allowed to use the division operator. So this is just some hints that they're giving, but the approach that I'm taking is slightly, it's quite an interesting problem. It can be solved in many different ways, but this is just my favorite approach. So before we jump into the coding, let's just explain what are the ideas that we need to understand. So firstly is that there's the existence of zero, and this makes a big difference in this question. So the minute we have a zero, what happens is that we can just assume that everything will be zero except for the item at that one zero index. So what do I mean by that? So let's look at this example, for instance. What are they expecting? At index zero, they are expecting the sum of these three things, which is 24. Hence, you have this. At index 1, they're expecting the product of this 1 times 3 times 4, which is 12. And 3 is 1 times 2 times 4, which is 8, and so on and so forth. Now, at in an array like this, regardless of whether you're negative, positive, whatnot, if you have a zero, if you're just 1 0, let's say you take this at index 0, you'll be expected to product all of these and you'll have a 0 inside. If you take this item, the second item over here, the first index over here, you'll have a 0 in it. If you take this, you will not have a 0 in it, and hence you would have to come, you can churn up with a value. But if you go to this, you'll have a 0 in the rest of the array, and if you go for this, you'll have a 0 in the rest of it. So the point I'm trying to say is, as long as there's 1 0, all indexes will be 0 except for the item at that index. So that's one. Now, if there's more than one zero, then what happens? Then your job is even easier. If there's more than one zero in the index in the array, we can just make the whole thing zero. Because if we mask one of it, like let's say if this is zero, if there was another zero, then the second we mask one of it, there'll still be a zero outside. If we mask this zero, there'll be another zero outside. So regardless of whichever, as long as it's more than one zero, we can assure that the entire array, or the product array of the thing will be full with zeros. So these are the broad ideas that we need to think about. Now, what is the solution? The idea that I'm proposing is something to do with this having a two-pointer kind of approach. So I'm ideating to create two arrays, one to count the product from the front and another to count the product from the back. So if I count the product from the front, it will be one. The first one will be just for one. The second one will be one times two, which is just two. The third one will be three times the previous one, which is six. And the last one is be 4 times 6, which is 24. That will be going from left to right. Now let's do the other way around, from the last to the first one. So the last item is 4. Okay. The second last item is 12. Then it will be 12 times 24. 12 times 2 is 24. Then it will be 24 times 1, which is 24 as well. So this is front and back. So how is this actually helping us? What can we do with this? So this is the input array that we're getting, 1, 2, 3, 4. So why is this beneficial? And I'll get to it quickly. So the idea that I have by forming this front and back is that the pattern that you can recognize is that um, for the answer, what we need this value to be hidden, but we need to have the product of everything else. And the value of the product of everything else could be in the front, could be in the back. Like for instance, if this is the index that we're choosing, it could be this value and this value. So it's on both sides. We cannot be running like a nested for loop, like multiply this and multiply. That's just not it. So by having these two arrays, we have a benefit, which is that at this point, we would have the product of all the things before it in the front to back list. And from this point, we will have the product of everything to its left in the back to front list. So what do I mean by that? Let's say, let's just answer this question. So answer, I'm taking index 1, index 0. At index 0, we need to multiply what came before it with what came after it. So what came before it would be nothing over here, so we can ignore that. What came after it is from index 0, what came after it at the back is 24. So let's put 24 for this one. Next up, at index 2, we need the product of everything that came before it and everything that came after it. So everything that came before its product would be this, and everything that came after it would be the product of, would be this. So it would be 12 times 1, which is 12. Now this item, the product of everything that came before it and the product of everything that came after it. So before it would be 2. After it would be 4. So 2 times 4, 8. Last one. 4, we need to find the product of everything that came before it, which is 6, and everything that came after it, which is nothing, so it is 6. And this answer is the same. So how does it handle if there's multiple, if there's 1 0 or like multiple zeros? Same thing. As long as it has a 0 at some point, it would understand like the left to right and right to left, it will auto fix itself and it'll just work as intended. So now let's try coding it out. And as we code it out, we will recap this logic again, and hopefully it makes it clearer. Some people visualize it better in code. So this is how I would code it out. So we will have a front variable and a back variable, and they will both be I'll just initiate it with the starting value. So it'll start with the front will start the first value and the back will start the last value. And yeah, for I in range 1 len nums, we will do front dot append nums I star front -1. Okay. So why do we do front -1? Because we will be appending nums I, which is in this case it would be the first index. So first index nums I multiplied by what came before it. So if it's this one, it'll be 3 multiplied what came before it. 4 would be 4 times what came before, which is 6, and it gives 24. So that's why we do this. So front -1 will give us the last item in the front variable array. Likewise, we would need to do this for the back as well. So back dot append back. This one slight edit. We will be going from the back to the front, right? Like right to left. So we need to modify the I stuff a bit. So by changing it to this, it'll be -1, -2, -3, -4. It'll just keep going like that. So that's that. And let's just print this to see what we're getting first to make sure we're not making any mistakes. I'll just comment these out. Ah, my bad. Okay. Yeah, it'll be wrong because we haven't returned anything, but we are getting what we expected. Something like this. 1, 2, 6, 4, and 24, 24, 12. For the reason why it's flipped is because we are appending from the front to the back. Like we are reading from right to left, but we are adding like as a list, right? So we are adding to the back every time. So we will see, we'll put 4 first, and then we'll put 12, and then we'll put 24, then 24. And this is very easily fixable. So if we like, I don't want to over optimize this. I'm just going to reverse the whole list in this way. But we can the next section doesn't really need it to work this way. But yeah, I just want to visualize this neater, so I'm going to keep it like that, and I won't use this for now unless I need to debug it. Then I will do this for I in range then nums. I will, if I is equal to 0, I will just append. Oh yeah, I need to create a finale array, like a final output array. I will do this. So final fin append back. So we are looking at if I is equal to 0, we will be looking at what came before, the product of what came before it and the product of what came after it. What came before it and what came after it. So before there's nothing, after there's this item. So it'll be back I plus 1. So that is if it is the starting one. The other edge case is if it is the last one. So if len nums minus 1, if it's the last item, then we need to find the product of everything that came before it and after it. And the after is nothing much, so we'll just focus on the before, which is 6 in this case. And to reflect that, we would need to do this front I minus 1. So we will look at the front and then whatever index we are looking at, which is the last index minus 1. So that is that. And the last one, if it's not either one of them, then we need to do fin.append. This will be the common case where we are looking at the front, whatever that came before it, multiplied by back and whatever that comes after it. So whatever that came before multiplied by whatever that came after, and that's how you get the final value of 12, for instance. And with that, we can return fin, and let's run. Hopefully I didn't make any syntax mistakes. Oh, I didn't. Okay. And we can run this. And nice. We passed the test cases, accepted and stuff. So, in terms of time complexity, this is not very inefficient. In fact, this could be trimmed. Like if we modify the logic of this, the bottom part a little bit more, we could trim it. But honestly, it's not worth it because it's already quite efficient. For instance, this is a n time. The time complexity of this is n. Like we go one time over here n, and this is also another n time complexity, so it's n plus n. And to reverse a string, reverse an array is also n, so it's effectively just linear time complexity. It doesn't exponentially explode if it's a really large test case. And that is good enough, actually. Like anything more is just trimming off like microseconds here and there, which, unless we are doing some competitive programming, doesn't really matter. So yeah, this is my solution for it. And it may take time to visualize these things, but you will eventually see the patterns in the different questions. And sometimes the same few tricks keep repeating itself, and it makes life much easier once you get familiarized with them. So yeah, that's my solution, and I'll see you guys in the next video. Hope you guys enjoyed it.